decided to go with word count. Minimize headache. So quick. Yes. This cough is gonna kill me. So you don't? You can do it? Of course, like just let's see how did they have any. Okay. This is what we need. Okay. Good afternoon, good evening, everyone. Today we're gonna start with some Hello World Spark activity. So we're gonna start with like what we did the first thing on Hadoop MapReduce, which is word count, but now it's more like Spark flavor of that. So hopefully you will find that informative. I'll leave it to Muhammad Ali now to start with the activity.
Maybe they have removed it again. They do it all the time.
They do that.
I'm getting used to it.
Okay, hello everyone, and welcome to this presentation. Today I'm going to use Spark to do the same task that we did in Hadoop, the hello world for the big data engineering word count example. But today we are going to use Spark instead. And you will see the differences and how Spark makes our life easier as an engineer. So by default, when we are using Hadoop, every pair that you are generated, it is stored in the disk. So it is not in the memory. So for example, when your mapper maps the input to some keys and values, all of them will be stored in the disk right away. So this is the problem. Writing and reading from the disk is time consuming. It is not efficient. And most of the time we can keep our data in the memory as long as we can keep it in the memory. So this is the main difference between Spark and Hadoop. The other difference that we like most is that in Hadoop, when you want to chain different jobs, you need to actually create different jobs and then pass the output of the first job to the next job, so you can chain it like this, as you are going to do in your assignment. But in Spark, you can chain anything with more ease without the need for storing the intermediate, values inside the disk. Another difference is that in Hadoop, we have always the keys and values. We cannot have only the key. Even when we want to read the data from disk, it is key and value. The key is line writable, showing the offset of our line, and then the value is the line itself. So maybe there are times that we don't need having both of them. So only value or a key is enough, like when we want to do the word count. So when we read from the file, we don't care about the offset of line. So if I am keeping the offset of line in my memory, I am losing resources. So let's start with the Spark. I will ask you to go to this page on the course website and download the Spark core jar file, as you can see here. So this is the first thing to do. Please log in into your CSC machines and then download the file. So the file is a bit huge, like 80 megabytes. You may face some problems on CSC machines. If you don't have enough disk space, you might need to remove some of your stuff from the machine. Okay, please open your Eclipse and then create a new project. I will call it Spark Hello World. Then you need to add the downloaded file to your project. You can do it by right-clicking on the project, then go to Build Path and add external archives. Next, add your Spark core to the project. Next, we are gonna create a class. So this is my work on class for Spark. Similar to Hadoop, we are going to create a configuration file, Spark conf. So you can set the master, which is responsible for creating and tracking the job. So set master. We are using our own machine, so the master should be localhost. So it is local. Then we can also set the name of our application, like word count. So reading is pretty easy in Spark. You just need to call this text file and give the path of your input file. Similar to Hadoop, we are going to use this args to get the input and output. So the input should be the first arguments in our program. So this text file will generate RDDs. So these RDDs are storage in Hadoop, in Spark. So they are usually in memory, but if the memory is not enough for storing the list, it will be stored on disk. So Java RDDs, it is a list of lines. So it is a list of strings. So this is also one of the differences when you are programming in a Spark. We don't need those writables anymore. So we can use just pure Java objects, and this will make also the programming easier. So these are the lines of the given text file. Next, we need to split each line to its tokens. Yeah. So I can use this input dot flat map, and then I need to have a mapper class. So I will call it first mapper. So I need to generate, I need to create this class which is called first mapper. And it should implement flat map function. The input is a string and also the output is a string. So if you click on the class name, there should be a drop box, and then you can add unimplemented methods that we need to implement. So this is similar to what we had in Hadoop. So we are getting a line of text or a sentence. Let's call it sentence. And then we need to return a list of words. So we need to split the text. for example, by space, then the output should be a string, a list of string. But we need to return an iterator for this list, not the tokens themselves. So we can return arrays dot as list. So this will convert the array of tokens to a list of tokens in Java. Then we can get the iterator by just calling this iterator function, and we will be fine. So this mapper gets a value without a key and then generate a list of values, again without a key. So there is no key so far. I will simplify the code by just using the split. I will remove this variable to have just a single line of code. So what is the output of my mapper at the moment? It is again a list of strings. Yeah, I can then just use the same input to assign the output of my flat map. So because it is also a RDD which contains a list of strings, so the output can be the same as the output of this flat map can be assigned to the inputs, or I can create another RDD called, for example, tokens. So next, I need to map each token to a pair of keys and values. The key is the word, and the value is the count, which at the beginning it is 1. So I can use again this map to pair function. So this function will map the input, which is just a single value, to a pair. So that pair can be, any kind of keys and values. So I will create second mapper. So let's define our mapper then. Again, this time it should implement the pair function, and this pair function will get a string as an input, and the output will be a string and integer. Okay, then click on the class name again and add unimplemented methods. Remove the auto-generated part. So this time the string that I am getting is just a token, I know it. And what I need to return is a pair of key and value, which is the word and 1. So I need to return a new tuple, and its value is token and 1. So I'm mapping each token to a pair, which the key is the token itself and the value is just 1. Later I will sum these values to calculate the count of each word. Okay, so what is the output of my mapper this time? It is Java pair RDD. So we have two kinds of RDDs then, simple RDD and pair RDDs. Simple RDDs are just values without any key, but pair RDDs are like the one that we had in Hadoop. So this time it is a string and integer. Let's call it token pairs. So what we need now, we need to reduce the same thing that we had in Hadoop. We need to reduce by key so we can add those values. So token pairs that reduce by key, and I need to create a function for reducing. Now I will call it reducer function, which I need to implement again. So public static class reducer function. And it implements function 2. And it will get two integers, the values, and then the output should be also an integer, which is the sum of two values. So click on the class name and add implemented methods, then return the sum of the given values. The output of my reducer will also be a pair of word and its count. So again, it is Java pair RDD. I will call it word counts. And we can save it as a text file or Hadoop file, object file. There are some options, or you can also implement your own saving approach. But in this course, we are using only text because it is easier to read. So we save it as a text file, and the output should be given by the arguments. I assume that it is the second argument of my application. I need to specify the argument, so I go to run configurations. Make sure that you are running the same class. Then the input, I'm assuming that I have this input.txt. I will copy it from the Hadoop tutorial that we had, and the output can be stored in the same directory as the output. Okay, I need to copy the file, so you also need to put the file in the same project. Make sure that you don't copy it to the source file, and it should be in the main directory of your project. Okay, I run my code, and I will check the output. So this is the output. It is a cell unordered. It is ordered based on the keys. Yeah? No. Even it is not ordered like that by default. So if you want to sort your output, you need to do it yourself. So any questions so far? So next, let's sort our output based on the count of words, not the words themselves. So for this, I need to have the counts as a key of my output. So then I can sort it. Because by default, we cannot sort based on the values. So I need to reverse my output to have the values and keys in different part of my pair. So I can use this word count, and then again I can use map function I need to swap the keys and values, so I need to create a new class. I will call it swap mapper, which implements function. And it gets a tuple. I can use map to pair instead. Map to pair, it would be easier. And then pair function instead. So we'll get a tuple of a string integer, and then it will create integer and a string. Then we only need to swap, call the swap function, which will swap the key and value. Just finish the code if you haven't. So the swap mapper will generate again a pair RDD, but this time the key is integer and the value is a string. So let's call it count. So next we want to sort our output. I can use this sort bar key, and then I need to define my comparator. So let's say integer. I have this integer comparator which I need to implement. Again, I need to create another class, public static class So I'm sorting in a descending way. So if you want to sort, your sort will want to be like ascending, then you need to reverse the order of objects, like O1 minus O2. So this function, this class can be used for comparing two integers, and we are passing it to our Spark job. So the Spark can sort the pairs based on the given function. So the output will be again a pair of RDDs. I will call it sorted counts. Then this time we will just write the sorted counts. So just pay attention here. You will face this error. Your task is not serializable. It is because of the comparator that we implemented. Make sure that you add this. Your class should also implement a serializable interface. So I need to just add this serializable, and that is all we need to do, nothing else. So serializable is similar to writables. So a writable is a serializable class that you can write and read from disk. Serializable is also something similar, but by default many of the Java functions, Java classes are serializable, so we don't need to serialize them. But here I'm creating a new comparator which needs to be also serializable. I don't need to implement anything. I just add this serializable to my definition of class. Just this, nothing else. Okay, let's remove the output from the previous run, then run the code again. And here is the output. As you can see, it is now sorted based on the counts. If you reverse the order of O1 and O2 here, the output will be sorted ascending. So I remove again, run the code. And this is the output this time. Still, I have written so many lines of code, and I created lots of classes. But I can do the same code just in a few lines of code instead of those classes. So in the next part, I'm going to use the new features from Java 8 that we can use to simplify our code. Instead of creating classes, then I can use what we have in Java 8. So let's simplify what we have written here. First of all, I don't need to just store these variables. I can just change them by using these dots. So for example, I first flat map, then I map them to a pair. Then I use this reduce function. Then again map to pair, sort the output, and then save it on the disk. So I don't need to keep the variables. I don't need them. But if you want to calculate based on the RDDs that you have created already, then you need to define those variables. But usually we don't need them. I can change the functions like this. Instead of creating classes, I can use Java's anonymous classes. So for example, here I can use this. I can implement the interface right in the code, like this. So it gets a string and also creates a string. Then add unimplemented methods. So we need to just use the same code that we created here. This would be the same as creating a new class. Instead of creating a new class, I am using this anonymous classes in Java. So such a class doesn't have a name, and we can only create a single instance of such classes because we don't need anywhere else to use this class. I'm just defining it right away in my code, inside my main code. And it is also easier for us to implement those functions because I can use this keyword new, and then if I just press space, then I will have this drop-down list and I can find the right interface to implement. Actually, I use this to remember what is the interface that I need to implement for each of the classes that I generated during this tutorial. Because there are not very useful names like function, function2. Who will remember what is this function and function2? But I can use just this syntax and then create my interfaces right away. So for the next part, I want to map a string to, it is exactly, where am I? Like I'm creating, okay. So the output should be a string and integer here. Then this one should return, I should implement the functions. So this is just a token. I can return new tuple. Also in Java 8, we don't need to specify this. It can detect it itself. So token and 1, hopefully. Yeah. Then next, I need to reduce by key. A new function I need to implement. So it gets 2 integers. I don't need to do anything. I just need to sum them. A plus B. Then I need to swap them. Again, I can use this new pair function. The pair should be integer and a string. And also, if you pay attention when I am writing the code, the IDE detects my input based on this chaining. I didn't enter like function to integer. It was there. So I just needed, I didn't enter like a string and integer because it is my input and it is clear based on my code. So I needed to only specify my output. Then I can implement again the functions. I need to swap them this time. So this is the pair. I can swap the pair by swap function. Then my comparator. I cannot do it for comparator because I have this. I have added, this serializable to my comparator. So I cannot use anonymous classes to implement two interfaces simultaneously. So that is why I cannot change this part. I will then remove the rest of my code. I don't need. I just comment them. So I will put the code on GitHub, so later you can also take a look at the classes if you want, but they are the same as these functions. But still I don't like my code. I can again simplify it by using lambdas in Java. So instead of, for example, just remember what we are doing here. We are just splitting the given token to a list of text. I will remove the code. I assume that I have an input like a sentence. I will call it S to simplify everything. And this S should be mapped to this. It is not working. I see. This should be S. Yep. So as simple as this. I have, for a given input, like this sentence, I want to split it to some words. And that is all. Instead of creating classes or anonymous classes, I just define my input and output. So let me just increase the font size. You can see what happened here. So for the next part, I can have this token and then create a new tuple. And the value is like t and 1. So it is like a map function. So I have, for a given token, I am just converting it to a new tuple with the same token and 1. Is it clear? Any question? So what do you think for the reducer? So just pay attention to the input. The input is 2 integers. Yeah? What is the output? A single integer. So I need to specify my input like A and B. So this is my input now, and I want to convert it to A plus B. I'm just reducing based on the value. So if you have more than one parameter for your function, then you can use these parentheses to specify your input. So these are called lambda function in Java. You have similar thing in Python. So in Python we use lambda a, for example, colon, then your output. Yeah, if you are a Python programmer. So this is the equivalent in Java. So what about the next one? Can you guess what is the lambda function for this one? We are going to swap the key and value. So what is the input? So the names that I am using here, they are up to you. You can use anything. For example, instead of S, I could use like sentence. So don't be confused here, like this. So I am defining my variables. I have like key and value here, and I want to convert it to value and key. So I can use this new tuple. Oh, excuse me, because this time it is just a pair. It is not like key and value. So I have this pair, and I can just call the swap function of the pair. So we can just take a look at the code that we have here. As you can see, the input is just a single object, and it is a pair, like a string integer tuple. So what I need only to call the swap function. So the rest is the same. So now our code is like this for the word count. And this is only configuration, and this is all we did for calculating the word count in Spark. I can test the code to see if the output is the same as before. As you can see, the output is the same, but we just wrote a few lines of code to do the same thing. So any question? So who was able to repeat the task while I was demonstrating? Who got the result? The word count by Spark? Only 2? And you? Okay, please ask your questions if you have any. If not, we are done with the activity then.
So for the students who have got the same results, final code, who are free to go. For the others who want to hang around to debug where you are stuck, feel free to do that. There's just one thing I wanted to mention in regard to the final exam. So currently I got approved for changing the weight for the final exam. So now it is 40% of the total mark. So like the distributions, 40% final exam, 25 assignment 2, 20 assignment 1, and 15 for the quizzes, just like it was before. So just like for your information, so that you know that we reduce the weight for final exam. And assignment 2 is going to be about Spark, so try to master it as much as possible. Okay, thank you.
Output, like the final output, will that be penalized?
The final output is just the person or the vector. You are not using any text. You don't use this text object, which is writer. You don't your output is a writable object, and you implement the string function to just write the text. So it is not a text.
So we have to
For the whole everything. For example, if you have a pair of movies, then you have a class called pair of movies. It has like 2 objects inside. Then exactly. Then to just define the width, right here, then implement the twist string.
what about this value?
So the value, you have an array of triples. So a triple can be a class, like user, rating 1, rating 2, and you have also an array writable, which you need to have the twist string, so you need to, if you have the array, then you can also have another, I don't know, writable class for storing this stuff. But the simplest one is the array writable.
Text and 2 string functions. Text is
Text is a writable object which you need to keep it in the memory. But the output that you are seeing, it is generated by the two string function. So it doesn't depend on the text writable. It's writing something For movie itself, you can use text, but for pair of movies, You are not alone.
So look at like from what you have. So you have here and you have let's say so probably if you want to look at
Compare the keys and
so like and the output
actually this is done by the habit itself in terms of when it is shuffling. So because all of the data for the same pair of movie should be directed to the same user. So without any function to compare these objects and see if they are the same direct them to the same. The keys should be rightly comparable. It is in the tips, but nobody. Yeah, I have that. Because we are busy thinking about the solution itself. I know. I was mistaken. I am mistaken.
that's why you need the type because like if you're gonna take it as definitely
Try to get the same.
that's why you need to
It's the name of it. So because we are going to compare two objects from this kind.
your first run, your first iteration also. And first matter of your job, then you are evaluating a complex object. So we don't want you to use it as text, consider it as text, because that will be consume it, and then if let's say you're working with real data, you're doing analyzing text file that's 1 terabyte, then your system is going to help.
Here you have this object.
For text, it is very memory consuming. That's why when you consume
You need to compare these two. Do you want to see if these pairs are the same? So how we compare two pairs of movies? You have two pairs of movies. So you need to have some code here to compare them. And you need to return if it is 0, it means that they are equal. If it is plus, it means that this one should be ranked above.
And the output of the
so like for the second part of the job, use your custom app for that. So that this is now it's a complex object. So use your custom app. Yes.
The custom one. What we use
The problem is like if you have told me
as Mike said, you don't use map writer, you don't use text or putting like pair of movie inside. I don't know if you
In the values only can, we have the text as a key and also the value and we write it will find. So that is
So, in the process, you have the writable classes, and if you implement the two strings, that will internally write them for you. So, still, you don't use these text, for No. For example, for implementing the pair of movies, you can have two text inside that. That is one.
对啊，他上次越多越
我把我这个文档在这个切
又要再写一遍吗？
It is a writable class which can be written on the disk itself. It shouldn't be text. So if you implement just the toString function, it will convert the object to a string, and then internally it will use it as a output.
反正每个人说的不一样。我说我
你就全写成
我
这个历史
太多了。
我要是全写成那个，根本就不用纠结那些，不用纠结。
问题他之前跟我说前面那个不重要。
你把所有的那个 write 都写上去，真的
不行，我得太麻烦了。
我就这么干的，就不会跟你纠结，全写成，就中间全写自己的 write， 后面全写成历史的 write， 就不用纠结，真的。
别讲话，等一下，你着急干啥？这刚12，回家干啥？
回家玩游戏啊。
If your output, your text, if you put like 2 pair of movies inside the text, you will lose one. If you put a list of objects into the text, you will lose one.
But in the first job, can I use the text for
When you are reading from the text file, yeah, you can use text. It is text. You are not using text, it is by default text.
Okay. So I can use
Then later you shouldn't see the text in your output. So this is the
map
text.
writer.
And don't use the map writable for your assignment. Avoid it. If you want to get the full mark, don't use map writable because it is such a huge waste of
I changed this part, just the first thing I did. So I create my own custom image.
Exactly. You have done it, you can easily do it.
Yes. But this the field like this one. If I change it, it could be
第一个输出，你第一个输出完的时候，你还要从那个文本里对，你读是对读太离奇。
longer for I don't know.
It depends on the output of your first job. You are passing the output of first job, to the input of the second. So based on what you write in the text, it can be different. Most probably you are writing in a text format, so the input of the second job will also be long and text. Then you need to parse the text and then
forbidden.
when you are reading from the file, text is fine. You cannot do anything else. You are using the class to read the file. It is text, and you are reading it from the text file. That is fine. When you are generating your keys and values, that part you can do.
Thank you. But when I use the first job, the first job will create a file text, right? So can the first reducer, the output can be text.